In this video, I'm going to go over graphing linear inequalities. So as we continue our study of linear equations, we eventually get to inequalities. And essentially inequalities give us a range of potential values. So say you have $5. When you go to the store, you may spend $5, but we have to spend less than $5. So that would be an equation of inequalities where we have a certain limit, but we can't really go over it. Okay, so let's look at just a couple types of problems here that you're going to be asked, and I'll go through the setup on those questions. So one type of problem is just checking solutions. So for example, is this particular coordinate, 1, 3, a solution of x plus y is less than and equal to 4? So all we do in this case is we plug in our values. So here's x, here's y. So we plug it in. So we have 1 for x plus 3. Is that less than or equal to 4? And in this case, we have 4 is less than or equal to 4. So this means that this is a solution. Okay? So now say we had a different value. Say we had the value 4, 2. Okay? So when we plug in 4, 2, we have 4 plus 2. Is that less than or equal to 4? And we find out it is not. So this is not a solution of the inequality we're given in the problem. So again, we can add complexity to it just by changing the setup of the coefficients of x and y, but you just plug the values x and y in and see if it makes the inequality true or not. If it's true, it's a solution. If it's false, it is not a solution. All right, then we get into this where we're actually going to start graphing inequalities that are linear in form. So let's take our example up here, x plus y is less than or equal to 4. So typically students like to graph in slope-intercept form. So if we convert this to slope-intercept form, we would subtract x from both sides and get y is less than or equal to negative x plus 4. All right, so we go over to our graph and we go up to plus 4, which is up here, that's our y-intercept. Now our slope tells us to go down 1 and to the right 1. And so we'll continue that trend all the way across the graph. Now, here's what's important and different from inequalities to equations. Now, in an equation, we would often plot our points and then draw a line all the way through connecting them, a solid line. Now, in this case, because it's also equal to, we're going to complete a solid line. But if the problem I gave you only had less than or just greater than, what we would do then is just put dashed lines like this. Okay, now that is very, very, very important. And we've seen this in the past when we have just, if you had x is greater than 3, okay? And then on a number line you had 3, did we fill in the circle or not? It's the same concept. So in this case, we would not fill in the circle because it's just greater than. If it was greater than or equal to, then we would fill in the circle. But now when we come to a graph, it's either a solid line or a dashed line. And so in this case, the original problem I gave you included it. So this will be a solid line. Okay? So now that we have our graph, we need to shade, all right? Because the shaded area is the solution. Now if we go back up here to the original 1, 3 was a solution to it, which is right here, and it ended up being on the line, okay? Well, we did 4, 2, so 4, 2 is up here, and this was not a solution. So when we shade in the area, it's gonna be dependent on the sign. So if it's less than the equation, we're gonna shade below. So what you would do is just kind of just shade down here. So anything below the line is true and would make that inequality okay. All right, so that's how you do it. Now, if it were greater than, we would shade above it. So the direction of the inequality will tell you where to shade. If it's less than, we shade down. If it's greater than, we shade up.